Hello everyone and welcome to Civil Curious channel. In this video we are going to discuss about the amplified earthquake, and what is overstrength coefficient. According to AISC code, we have to design our columns for amplified earthquake just in axial load. It means that there is no shear load, there is no moment, and how we are going to do that. As you know, we have a coefficient that we call it overstrength coefficient in ASCE code. According to ASCE, we have the overstrength coefficient. Can you write that? You see, this is overstrength coefficient, and how we can control the amplified earthquake. Amplified earthquake is the earthquake that we have the overstrength coefficient times the earthquake loads. That earthquake loads include earthquake in x direction, earthquake load in x direction positive and negative. Also, we have earthquake load in y direction, earthquake load in y direction positive, and earthquake load in y direction negative. You see, and we are not gonna make that load combinations all. We just scale our earthquake loads. You see. Now let's do that in ETABS. I've just opened the ETABS. As you know, as you can see, we have braces in our y direction and we have moment frame in our x direction. The coefficient, the overstrength coefficient in y direction that we have braces is 2 according to ASCE, and the coefficient, overstrength coefficient in x direction according to ASCE is 3. For doing this, controlling the columns for amplified earthquake just for axial load, we have to deceive ETABS. How? We tell the ETABS our columns have many strengths, has much strengths in bending or shear. How can we do that? Like this. I select all of my columns. And then I go to design menu, steel frame, view reverse overrides. Here in the bottom of the page, we enter the value of bending strength, bending capacity too high, like this, 1E20. Both for bending and shear capacity. It means that there is no shear or bending because our columns are very strength in bending or shear. Okay, now we go to our load cases and we enter the overstrength coefficient as a scale factor. I told that the scale factor or overstrength coefficient is 2 in y direction. And in x direction, our coefficient is 3. Sorry. We have the coefficient 3. We have the coefficient 3. And its name is EXP. Okay. Now I analyze my structure. and then I design my columns. Okay, now let me select again my columns and show that just. Okay, from the display menu here, I chose identify PM failure. PM is about axial load. When I going to identify PM failure, it means that I'm gonna see what columns have problem in axial load. It means this. As you can see, there is no red columns that show us the over ratio for columns. All of columns have enough capacity in amplified earthquake. You see, that was all, everybody, for axial load in columns due to amplified earthquake. I hope you all enjoy it, and if you like it, please subscribe to the channel to motivate me to create more videos for you, everybody. Thank you very much.